Hey there, I'm TJ Van Tol, and I'm a Principal Developer Advocate at Blues. This video is the second in my series, Building a Connected Product with Notecard. In the first video, we covered the hardware components of a Notecard-based project, including how to pick a note card, a note carrier, and a host microcontroller. We looked at how to select hardware for the two different products we'll be building together throughout this series, the air quality monitor, AirIQ, and the vehicle tracker, TempTrack. This video is on configuring Notecard. We'll break down the common Notecard configuration requests in a lot of detail, and then we'll look at how to apply those learnings to our two sample projects. Let's start by breaking down what I mean by Notecard configuration. All Notecards are system-on modules that you can communicate with by sending them JSON over I2C, UART, or USB. The format of the JSON requests you can send to a Notecard are documented in the Notecard API section of the Blues documentation. Many of these requests only return information from Notecard. For example, the card.version request returns metadata about your device, and the card.location request returns the best known location of your device. Many of these requests, however, change how a Notecard works. And configuring those requests appropriately for your project will be the focus of this video. Now, there are quite a few requests that you can use to configure Notecard. So for this video, I've picked out all of the requests that I feel are important for all Notecard users to understand. And essentially, I'll be going through these requests in sequence. I'll cover what each request does, and then show how we'll be configuring each request for AirIQ and TempTrack. This video's description has timestamps for each request, so if you want to skip to a specific one that you're just curious about, just know that those links are available. One last thing before we start. Personally, I like storing my Notecard configuration in a JSON file. It's a file I store in source control along with any firmware or scripts I build along with my projects. For example, just so you can see what one looks like, here's the config that I'm using for a separate project. This is a CO2 home monitor that I have running in my house, and you can see all of the Notecard requests that are part of the config that I have defined. These JSON files are just great to have as a reference, and there's a really cool feature of the Notecard CLI that lets you apply all of the configuration from a JSON file to a Notecard, and we'll look at how to do that at the end of this video. All right, let's get started, and we'll start with the single most important request for every Notecard-based project, hub.set. The hub.set request controls how often your Notecard connects to NoteHub and synchronizes data. All Notecards need to use this request to, at a minimum, set a valid product UID from your NoteHub project in the request's product argument. This is how your Notecard knows which NoteHub project to synchronize data with, and your Notecard is kind of useless until you set this. Once you have a product set, you'll next need to set a mode, which essentially acts as the strategy your Notecard will use to connect to NoteHub. There are a few different Notecard modes, but the two main ones are periodic and continuous. Periodic is the default mode. When in periodic mode, Notecard will connect to NoteHub at configured intervals, but not maintain a constant connection to save battery. Whereas in continuous mode, Notecard maintains an always-on network connection. Continuous mode uses more battery, but it saves you a lot of latency as it prevents your device from having to initiate a new connection anytime you need to send or receive data. Regardless of whether you pick periodic or continuous mode, how often Notecard sends or receives data is controlled by the hub.set requests next to arguments, outbound and inbound. Outbound tells Notecard how often it should send any data that's queued locally out to NoteHub, and inbound tells Notecard how often it should receive data that's queued on the NoteHub side in to the device. This is easier to understand with a few examples. Let's start with this config that tells Notecard to run in periodic mode and to send data out every 60 minutes or every hour, and to check for any updates from NoteHub every 180 minutes or every 3 hours. Let's say you run this request at 1 o'clock, just to make the math easy. Then at 1:15, you use your Notecard's note.add request to queue a temperature reading on your device. When you queue up this note, nothing happens immediately. Notecard isn't going to do anything with this data until it hits its next outbound interval, which in this case will happen at 2 o'clock. At 2, Notecard will start a network connection and synchronize this outbound temperature data with NoteHub. When it's done, you'll see your note appear in your NoteHub project as an event. One cool thing, Notecard is smart enough to only perform a network connection for outbound data if it actually has outbound data to send. So to go back to our example, suppose 3 o'clock rolls around and we haven't queued any additional notes or changes on our device. In that case, Notecard will just skip making that connection and check again whether there is any queued data at the next outbound interval. That's the outbound flow. Now, suppose it hits 3:30 and we need to update an environment variable on our device. Quick aside, if you're new to Blues and you're not sure what environment variables are, we'll cover them at the end of this video, but for now, just know that they're values you can set on NoteHub and synchronize down to your devices. So let's say we go into NoteHub and update a variable. Let's say we set an interval to 60 and save that change exactly at 3:30. Once again, with our current config, Notecard is not going to pick up on this change immediately. Instead, it's going to wait until the next inbound interval, which, because we started at 1 o'clock and set our inbound interval to 3 hours, will be at 4 o'clock. So at 4, Notecard will perform a network connection to NoteHub. It'll check and find the updated environment variable, and it will download it to your device. Inbound changes include environment variables, inbound notes, and also Notecard and host firmware updates as well. When you queue any of those things up in NoteHub, it's an inbound synchronization that actually brings those changes down to your device. And unlike outbound intervals, inbound intervals can't be skipped, which makes some sense if you think about it. Notecard knows what it has queued locally, but it can't know if there will be any changes on NoteHub until it looks. So if you have an inbound interval configured, Notecard is going to look every time, even if there aren't actually any changes queued on the cloud. Let's look at another example, and this time change our mode to continuous. We'll again assume we set this configuration at 1 o'clock, and at 1:15, we again use Notecard's note.add request to queue a temperature reading. A lot of people assume that Notecard will synchronize this note immediately because you are in continuous mode, but it actually won't. Continuous mode controls whether Notecard maintains a continuous network connection, but it doesn't affect how often data synchronizes. By default, this note will synchronize at 2 o'clock, just like it did in periodic mode. If you want to sync this note immediately, you can add a sync true flag to the note.add request, or you can run a hub.sync request manually. Either of those will sync your outbound data, and that sync will happen pretty quickly since your device has an active connection in continuous mode. Let's next look at the inbound flow again. If we take the same step as before and make an environment variable change at 3:30, once again, Notecard is not going to pick up on that change until its next inbound interval, which per our configuration will again happen at 4 o'clock. There is, however, a flag you can use if you want to receive inbound changes immediately when in continuous mode, and that's the sync flag, which you can include on your hub.set requests. With the sync flag set, if you make that same environment variable change at 3:30, you'll receive that change on your device at 3:30, or 3:30 plus a second or two. If you're building any sort of smart home type of project where you need to react to inbound changes immediately, you'll definitely want to try out the sync argument. But note that the sync argument is not available on Notecard for LoRa or when using Notecard with StarNote, as those protocols don't have any ability to do these sort of low latency requests. The next argument of hub.set I want to discuss is duration. And to do that, I have to take a step back and explain what Notecard sessions are. Every time your Notecard makes a connection to NoteHub, it establishes a new session. And Notecard also synchronizes some additional metadata that is not available on every note. That data comes through in two different _session.qo events. One for when the session begins, and another for when the session ends. For example, I'll bring up one of my NoteHub projects real quick to show you. Here's an event for the start of a session, and you'll see that I have the radio access technology this session was started with, in this case LTE, some data about the signal strength, the voltage of the device, whether it has USB power, which this device did, and so on. And then for the end event, I have some data related to usage, how much data my device sent during the session, and so on. This data, both at the start of a session and the end of a session, can be really valuable metadata. And we're definitely going to be using a lot of this for both AirIQ and TempTrack. So to bring this back to the duration argument, which is what we started this for, remember that sessions are only created for new connections to NoteHub. And if your device is in continuous mode, you'll likely always be connected, and so you won't be starting new sessions. To account for that, if you're using continuous mode, you can also set the duration argument on a hub.set request to the number of minutes after which NoteHub should create a new session. The last two arguments of hub.set I want to discuss are v-inbound and v-outbound, which are both important if you're running your project on battery power. Here's an example so you can see what these arguments look like. This is another hub.set request, except this time instead of using outbound and inbound, we're instead using v-outbound and v-inbound. These arguments take what we call voltage variable values, which essentially give you a way to automatically vary your outbound and inbound values depending on the state of your battery. For instance, to take this v-outbound configuration as an example, this syntax says to set outbound to 30 if this device has USB power, to 60 if it has high power, 90 for normal power, and so on. If you use v-outbound and v-inbound, there's another Notecard request you must use called card.voltage. Card.voltage is how you tell Notecard what your power source is so that it can map those high, normal, and low strings to actual values. For example, suppose we're powering our device with a LiPo battery. We can make a card.voltage request with our mode set to LiPo, and then make our hub.set request with a v-outbound and v-inbound. Here's the voltage values Notecard uses for LiPo batteries as a reference. So to put this all together, when our device first powers up on a LiPo battery, our voltage will probably be somewhere around 4.1 or so, which Notecard will consider high, and will therefore use an outbound value of 60 and an inbound value of 120. When the battery drops under 4.0, it'll cross into normal, and Notecard will automatically switch you to an outbound of 90 and an inbound of 240. This automatic shifting can be really powerful for any project that runs on battery power because it helps you conserve energy as your battery starts to run low, and it's super configurable. All right, I could spend another hour talking about the hub.set request alone, but to keep this video digestible, I'm going to wrap up with two last notes about this request. First, there are two additional hub.set modes, minimum and off. In minimum mode, Notecard doesn't perform any automated synchronizations. It only connects if you use a hub.sync request. And off mode is essentially airplane mode for a Notecard. In off mode, Notecard doesn't make any connections at all. These modes are valuable in some apps, but Notecards cannot perform over-the-air firmware updates when using either of these modes. So we recommend only using these if you really need to carefully manage how your Notecard connects to a network. Second, hub.set also has uperiodic, umin, and uoff flags. The U in these names stands for USB, and what these flags allow you to do is put your Notecard in continuous mode when your device has USB power, and to fall back to a different mode when your device loses USB power. So, for example, with this configuration, your Notecard will be in continuous mode when plugged in, and in periodic mode when it is not, which is pretty cool. All right, so with that long conversation out of the way, let's talk about our example projects. Here's what our starting configuration is going to look like for AirIQ. AirIQ will run on a lithium-ion capacitor that we have in our enclosure, so I'm setting the card.voltage request to a mode of lick. And then for hub.set, I'm setting the mode to periodic because we do want to conserve battery for AirIQ. It's going to be a solar-powered project. Because of that, I'm also using voltage variable values for inbound and outbound. With a full battery, Notecard will send out readings every hour and check for new inbound values every 720 minutes, which is once every 12 hours. I then crank down those intervals for when the battery starts to drain a bit. Sometimes you need to play with these values in the field for a while to see how they perform in real conditions, but this is a pretty reasonable starting point for a solar-powered outdoor device. And for TempTrack, the values we're using are somewhat similar. TempTrack will be USB powered when the vehicle is active and use a LiPo battery for power when the vehicle is not active. Because we're using a LiPo, I'm passing LiPo as a mode to card.voltage. For hub.set, I'm again using voltage variable outbound and inbound values for TempTrack. I have my device syncing inbound and outbound every 30 minutes while active with USB power, and much less aggressively when the vehicle is not active. The reason I'm setting TempTrack to sync every 30 minutes and not more frequently is because cellular note cards cannot do both GPS positioning and cellular tasks simultaneously, and I want to make sure the GPS module has time to do its thing. If you do want to do more aggressive tracking and syncing, you can use an external GPS module with Notecard. I'll have a link in the description if you want to learn more about that. But for this project, I wanted to keep it simple and not make the hardware more expensive to acquire and more difficult to work with. Plus, I don't actually need frequent syncing for TempTrack anyways. This device is intended to be a somewhat passive tracker that syncs right away if I detect a temperature outside of a certain range. That's what's going to put the temp in TempTrack. But that's a problem we're going to solve via firmware in our next video, so we should be all set with our current configuration. And I think that's it for hub.set, so let's take a deep breath, and I promise the next request won't take nearly as long to cover. Our next request is pretty important though, and that's card.location.mode. The card.location.mode request configures GPS-related settings for your note card. The request takes a mode, which you can set to one of 4 values. Off is the first, and as its name sort of implies, this value turns off all GPS-related functionality on your note card. If you turn off GPS, you still have other ways of getting a location. All Wi-Fi-based note cards can perform Wi-Fi triangulation, and all cellular-based note cards can get a location based off of cell tower triangulation. So if you want to rely on those and have no need for GPS, you can turn it off. Periodic tells Notecard to periodically retrieve a GPS location. When using this mode, you use a second argument, seconds, to tell Notecard how often it should retrieve a location. One cool thing though, Notecard is smart enough to only get a new location if it detects movement via its onboard accelerometer. The idea there is if a note card hasn't moved, there's no reason to waste battery to retrieve the exact same location. The next mode, continuous, tells Notecard to enable continuous sampling from its GPS module and to take a new reading for every note that you create. This is a mode I really only recommend using if you do have an external GPS. Notecard doesn't even allow you to set continuous as a mode for both your hub.set and card.location.mode, and if you try that, you will get an error. And finally, fixed is a way you can give Notecard a location that you retrieved elsewhere. This mode is really only used with Notecard for LoRa, as LoRa-based note cards don't have a GPS module or a Wi-Fi module for triangulation. So if you're using LoRa and you have some external means of getting a location, you could use fixed to tell Notecard about a latitude and longitude so that Notecard can include it on notes. Periodic is the most commonly used mode, and it's what I'm going to be using for both AirIQ and TempTrack. For AirIQ, I'm going to sample every day by setting seconds to 86,400, which is the number of seconds in a day. AirIQ shouldn't really move once it's installed, and because Notecard is smart enough to not get a location if there's no movement, in practice the GPS module won't do much once it has an initial location. But I like enabling this request. Having a location being sent to NoteHub can help you show your devices on a map, even if they're stationary. And if this device ever does move unexpectedly, maybe someone steals it or whatever, this config will ensure that you get daily check-ins from a device on the move. For TempTrack, we are going to want to take location readings more frequently because this is a device that will be on the move on purpose. So I'm setting seconds to 300, which is every 5 minutes. So when TempTrack is actively tracking, it should take a GPS reading every 5 minutes. And that's card.location.mode, which again configures how the GPS module on Notecard is going to work. Next, we'll talk about the other big GPS-related Notecard request, and that's card.location.track. This is a request that's specifically for asset tracking. If you start card.location.track, which you can do by making the request with the start true argument, Notecard will start regularly storing location data in a note file for you. Let me give you an example. Let's say you have your card.location.mode configured to take location readings every 30 minutes, and that you have card.location.track started with the start true argument. What's going to happen is Notecard will automatically create a note in a _.track.qo note file every time it takes a new location reading. By default, Notecard is only going to create a note and not sync it. How often those _track.qo notes sync to NoteHub is still going to be determined by the outbound interval you configured in your hub.set request. In general, the reason this request exists is to make it easier for you to store and transmit your location data. There's one argument this request accepts that I want to cover, and that's heartbeat. If you enable a heartbeat, Notecard will take a periodic location reading even if your Notecard hasn't moved. How often Notecard should take that reading is determined by the hours argument. So for a full example, if you use this config and set heartbeat to true and hours to 24, your Notecard will attempt to retrieve a GPS location every 24 hours, even if your device hasn't moved at all, and store it in a _.trackqo note. In my projects, this has been a very useful check-in. You'll get this note even if your device can't get a GPS location, which in and of itself is useful to know. Maybe your device is in a metal facility or whatever. And if you can't get a GPS location, you'll still get the best location your device can ascertain, which might be a Wi-Fi triangulated location or a cell tower triangulated location. All right, one last note about card.location.track, and then I'm going to show you some data. If you have a BME 280 or ENS 210 sensor connected on the I2C bus, Notecard will automatically include environmental readings from those sensors along with your tracking notes. And you'll see that in action for TempTrack here later on. All right, to try to put all of this in context, let me show you what some of this data looks like in NoteHub. Okay, I brought up a NoteHub project of mine for a tracker I've been using for testing. And for this project, I have card.location.mode set to take readings every 5 minutes, and I have card.location.track enabled. You're looking at the events view for this project, and what I'm going to do is start by filtering for _track.qo, or events from the _.trackqo note file, because that's the main thing I want to show. Next, I'm going to make sure I am viewing the captured column, which is a good idea to do for trackers because you pretty much always want to know when a reading was taken and not when that reading was uploaded to NoteHub. And captured is going to show when the reading was actually taken by the device. If I do that and start scrolling a little bit, you'll see that the readings are taken every 5 minutes apart while this device was in motion. To see the actual location, I can click into one of these events and switch to the JSON tab. On this event, you'll see that we actually have a variety of locations. I have a cell tower location in the tower prefixed fields and a GPS location in the where prefix fields. I was using a cellular note card for this test, so I don't have a Wi-Fi triangulated location on these events, but if I did, they'd be listed here with a try prefix. There are also these best prefix fields, which is the location that NoteHub feels is likely the best location of your device of the available options. By default, NoteHub is going to consider a GPS location best, and then a Wi-Fi triangulated location, and then a cell tower triangulated location. But there is a little more to the algorithm that NoteHub uses for best. NoteHub considers location readings that are 3 days old stale. And so, for example, if I park this device in a garage for a week and I couldn't get a GPS location, and in the meantime, I got a more up-to-date Wi-Fi triangulated location, after those 3 days, NoteHub would switch my best location over to that more up-to-date reading. If you want to read about locations in NoteHub and how NoteHub handles the best location in more detail, I have a link to our documentation on the topic in this video's description. But overall, I just wanted to show you what location data looks like in NoteHub so you can see how your configuration translates into actual data that you can use. With that background out of the way, let's return to our sample projects. We can skip the card.location.track request for AirIQ, as it's a stationary project that we don't need to track at all. If an AirIQ device gets stolen, we'll still get readings every 24 hours because of how we configured card.location.mode. But for TempTrack, we do want tracking. So we'll use the same config that I actually showed earlier and enable tracking with a heartbeat reading every 24 hours. All right, before moving on to our next request, I want to take a quick aside to talk about Wi-Fi triangulation in a little more detail because I think it's very useful. Wi-Fi triangulation is enabled by default on all Notecard Wi-Fi and Notecard Cell plus Wi-Fi devices. How it works is Notecard will scan for Wi-Fi access points and the signal strength from those access points and send them to NoteHub in a _geolocate.qo note. NoteHub will then use that data to look up a location, and you'll see that triangulated location associated with your notes. If you're in an urban or residential area, this location can be surprisingly accurate. I live in a suburb, and my triangulated location is accurate to within a few hundred feet, just as an example. A few notes, though, about Wi-Fi triangulation if you do try it out. First, Notecard will gather geolocation data at the start of a session, which remember is determined by your hub.set request's outbound argument in periodic mode, or hub.set request's duration when in continuous mode. Notecard will also only gather this data if the device has moved, which, like with GPS, makes some sense. If your device has moved, in theory, the access point data should be the same. And finally, on the NoteHub side of things, there is a setting related to triangulation. The default limits all devices to daily lookups. So if you have a need to get more frequent updates, you'll have to adjust that setting accordingly. Wi-Fi triangulation is really useful for a project like TempTrack. TempTrack is intended for commercial vehicles, and vehicles like that often park in garages or in other areas that have no GPS signal. And Wi-Fi triangulation gives a really useful and surprisingly accurate fallback for those situations. And whether you realize it or not, you've probably already seen Wi-Fi triangulation in action. If you've ever been in a large indoor space, like a shopping mall or in an underground location, and wondered how your mobile phone knew your location, at least approximately, it's likely in part due to Apple or Google using nearby Wi-Fi access points for location lookups. All right, that was a long aside for triangulation, but I wanted to cover it because it is directly related to Notecard configuration and can affect how you configure your location settings in general. But we're leaving location now and moving on to another important feature of Notecard, and that's firmware updates. Notecard has the ability to remotely update not only its own firmware, but also the firmware of a connected host microcontroller through a process we call Notecard Outboard Firmware Update. To use Notecard Outboard Firmware Update, you have to enable the feature using the card.dfu request. You can enable updates by passing this request an onTrue argument as well as a name argument. The name argument tells Notecard about the architecture of the host device that you're using. The first two options are pretty obvious. You can use ESP32 for ESP32 based hosts and STM32 for STM32 based hosts. There are two other options. Some STM32 based hosts have their boot pin inverted, and that's what the STM32-BI option is for. And then finally, the MCU boot option is for some Nordic hosts that use the MCU boot for their bootloader. Don't worry too much about screwing this request up. You're not going to do any permanent damage or anything. If you pick the wrong config, host firmware updates just won't work, and you'll know you'll have to look into this. And we'll be covering host firmware updates in the next video. For our two sample projects, the card.dfu configuration is very straightforward. Both of our projects use STM32 based boards, the Blues Swan for AirIQ and the Blues Signet for TempTrack, and therefore we'll set the name of each to use a, name of STM32. All right, next on our list of requests is the note.template request. Note.template provides a mechanism for defining a schema for the data you place in note files. The main benefit of templates is data savings, as Notecard can more efficiently store, compress, and transmit your data by knowing its structure. Templates are actually required if your project uses LoRa or satellite, as those data savings are critical when working on those lower bandwidth protocols. Even when working on cellular though, the data savings you get from templates are still nice. Using less cellular data is always a good thing. So we do recommend defining templates for each note file you intend to use. The other nice thing about defining templates at this stage is it kind of acts as a planning step. Before you get to your host firmware, you kind of already have a plan for the data that you intend to store and the format you intend to store it in. Defining a template with the note.template request looks a little something like this. The file argument is required and should be set to the name of the note file you're defining. In this case, readings.qo. And then the body lists out all the fields your note file will use. The value for each field tells Notecard about the data type you intend to use for that field. There's a list of the valid values in the Blues documentation, and I always bring up that list when I'm defining templates, so I'll do that in this video too. For this example, the field newVals is given a value of true, which defines it as a Boolean field. The field pump state is given a value of an empty string, which defines it as a string field. The field age is given a value of 22, which makes it a 2-byte unsigned integer. And as you can see from the list, there are a number of different types of values you can use for integers, depending on the values you intend to store in them. And finally, the field temperature is given a value of 14.1, which defines it as a 4-byte floating point number. And like with integers, with floats you can use a few other values depending on the size of the values you intend to use. Once you have your template defined, you just use your note file like you would any other note file. For example, here's what it looks like to add a note to the readings.qo note file shown above. All we do is provide values that match our defined template. So what is this going to look like for our sample projects? Well, for AirIQ, there's only one note file we're going to be working with, and that's going to contain all of our air quality readings. The sensor that we're using, the PMSA003i, returns quite a bit of data. And at this stage, I'm not positive we're going to be using every value when we get to building dashboards and such, but I do want to include all the values in my note file, and that ends up looking like this. I'm using a value of 22 for all of these fields, and 22 is the value of a 2-byte unsigned integer, which means values between 0 and 65,535. I picked these values because, and this is a bit of a look ahead into the next video, The firmware library I'll be using that reads data from the PMSA 003i stores all these values as uint16s, which are 2-byte unsigned integers. The one thing to be careful of when using templates is that if you try to add a note to a note file that doesn't conform to your template, you will get an error. Because of that, you'll want to take some care in your firmware to essentially make sure that that doesn't happen. And using the same data types consistently is a great way to enforce that. For TempTrack, I don't need to define a template for _track.qo because that is a built-in note file, and that note file is how most of our data is going to be transferred for that project. I am, however, going to define one note file for the device, and that's for alerts. For TempTrack, we're going to monitor the temperature of the device while it's in motion and send out alerts if it leaves a configurable range. And so for those alerts, I'm going to use the following note file. I'm going to call the note file alert.qo, and I'm going to include the temperature as well as the configured minimum and maximum thresholds. We're going to store these thresholds in environment variables, and we'll walk through how that works in the next video. But I like including the thresholds in the events themselves too. It'll make things easier to debug if anything does go wrong. And with that, we have our templates. And at this point, we've covered most of the requests I want to walk through. There's one last small one, and that's card.wifi. This is definitely the easiest request to cover in this video because it's pretty straightforward. Most of the time when you use this request, you just give it the SSID and password of your Wi-Fi network. There are some other cool things you can do with card.wifi. You can provide multiple access points with the text argument if your device is moving between locations or something like that. There's also a really cool feature where Notecard can create an access point that you can use to configure its Wi-Fi connection. There are physical buttons on both Notecard Wi-Fi and Notecard Cell plus Wi-Fi that launch this. And if you do that, you can configure the landing page that Notecard uses with the card.wifi requests name and org argument. If that's useful for your projects or sounds interesting, I have a link to our Wi-Fi documentation in this video's description. For now though, I do want to set up a network for TempTrack. TempTrack uses a Notecard Cell plus Wi-Fi, and it will have a home base, my house. And if this were a commercial project, the vehicle likely will have some sort of base garage or facility. And so I want to set that up so that TempTrack uses Wi-Fi when it is available, which will help me save on some cellular data. And I can leverage the Wi-Fi to cellular fallback that's built into the Notecard Cell plus Wi-Fi. All right. Take a deep breath because that is the end of our list of requests. But we're not done quite yet, as to end this video, I have 3 last configuration topics I want to cover. The first is how to use the JSON configuration files we've been creating for our projects. Second, I want to talk about how to reset a note card in case you screw something up and want to start from scratch. And lastly, I want to talk about some built-in environment variables that you can use to change note card configuration in the field. All right, first topic, let's load this configuration. Okay, you're now looking at my desktop, and I have the documentation for the Notecard CLI up, which is our command line interface that's available for Windows, for macOS, and for Linux. And it's what I'll be using to run the JSON setup scripts for our projects. The first section in this guide covers installation. So I'll have links to this guide in our video's description so that you can run through the installation yourself. But the easiest way to install is through Homebrew, which you can do on macOS and Linux, and also the Windows subsystem for Linux. If you have Homebrew, installing is as easy as running 2 quick commands. I do have the CLI installed already, so I'll go ahead and bring it up. And the first thing you can do once it's installed is just run the Notecard command. This is going to give you a list of really everything that you can do with the Notecard CLI. The CLI will automatically detect whether you have any note cards available via USB. And if you look down here, I have stars next to this one, meaning that the CLI automatically detected a note card. And in this case, it's a Notecard Cellular. It's the one I plan to use to test AirIQ. And I have it connected to my laptop via USB. And I can verify that and also get some more metadata about my note card by running notecard-info. I can see that this is a Notecard Cellular, but that otherwise this is essentially a brand new Notecard. I don't have a product UID or really anything else set on this device. To load that config, I'm going to use the setup scripts that we've been building up. So I have one for AirIQ over here. And I also have a one-line version of this because at the time of this recording, the CLI does require each request to be on one line. That's a restriction that hopefully should be lifted by the time you're watching this, but just in case, I thought I would mention it here real quick. Regardless though, to load these scripts, I'll go back to the CLI and I'll run notecard-setup, and this is going to take a path to the script that you want to use. So in this case, the AirIQ one-line.json file, and I'll just go ahead and run this. And you see it'll go sequentially through my commands and set them up. And in theory, if we run notecard-info again, we can make sure that all of this worked. So we have our product UID in here now. You can see that our outbound and inbound have those voltage variable values that we configured. We have a note file set up as well. And so yeah, at this point, our device for AirIQ should be good to go. And since that worked fine, I'm going to do a little bit of reconnecting. I'm going to unplug my Notecard Cellular for AirIQ, and I'm going to plug in the Cell Plus Wi-Fi Notecard that I plan to use for TempTrack. And I've got that done, so I'll again run Notecard and make sure I've got a device. I've got it there. I'll run notecard-info again, and you'll see I have another device that's basically brand new. I don't have a product UID set. This is a Cell Plus Wi-Fi note card. And so what I'm gonna do is take our setup script. So I've got the TempTrack one over here, and once again, I've got another one-liner version ready for this one also. So let's load that by once again running notecard-setup. We'll pass this thing a path to our one-liner and just run it. And we'll once again verify that that worked. It looks like it did, but we'll run -info. And you'll see that we have a product UID set for this one. We've got our outbound and inbound periods as well. We've got that alert.qo note file set also. The CLI is complaining because we don't have a time. It gets that from syncing, which we've not done on this device quite yet. But at this point, we should have both of our note cards set up and good to go. I like doing my configuration through these setup scripts because I like planning out my projects before I get into firmware. Don't worry though if you want to do your Notecard configuration manually through the Notecards in-browser terminal or just build this up as you go though. It's not super important exactly how you load your configuration for now. Long term though, having repeatable processes like these setup scripts becomes more essential as your project scales. Doing configuration manually is fine for one device, but if you start to work with tens or hundreds or even thousands of devices, having a quick script you can run makes your life a lot easier. All right, the next thing I want to cover is resetting your Notecard configuration. It's basically inevitable that at some point during your development process, you'll need to reset some requests or maybe even an entire Notecard, so it's a good idea to know how to do that. First, the Notecard API has a mechanism for resetting both string arguments and numeric arguments to their default values. You can reset a string by passing a dash and reset a numeric argument by passing a -1. If you ever want to completely reset a Notecard, you can do so with the card.restore request. When you run this request, you usually also want to include the delete argument, which tells Notecard to remove its product UID, and the connected argument, which removes your Notecard's environment variables and note file templates. One small note though, there are a few pieces of configuration that are not reset by a card.restore request, and those are your Wi-Fi settings, any custom I2C address that you may have configured with the card.io request, which is a bit of an uncommon thing to do, and any NTN settings if you're using a star note alongside your note card. The factory reset guide in the Blues documentation, which I'll also link to in this video's description, has specific details for resetting each of those settings if you're interested. And all right, that brings us to the final topic of this video, and that's how to change your Notecard configuration in the field. It's all well and good to create a setup script with all the configuration you think is perfect, but if you worked on any real-world projects before, you know that things change, and having the ability to update your configuration on live devices can be mission critical. I'm going to give you a small taste of the sort of configurability you can build into your products now, and save the full discussion for our next video when we're going to work on our host firmware and really dive in. The easiest way to make your products configurable with Blues is with environment variables. Environment variables are key value pairs that you can synchronize across devices and across fleets of devices. The variables themselves are values you set in NoteHub, either in the NoteHub user interface or using the NoteHub API. The values you set are downloaded by your device at its next inbound interval. Blues offers a few dozen reserved environment variables that provide built-in ways of configuring live note cards, and many of them act as overrides to a note card configuration setting. To take one example, TempTrack uses the card.location.mode request with a second argument set to 300. Suppose I get 10 TempTrack devices in the wild, and after seeing real data come in, I decide I want to try taking more frequent readings. What I could do is go into NoteHub or use the NoteHub API and set the _GPS_sex environment variable to an override value, let's say 180 for every 3 minutes. When my note card gets this environment variable on its next inbound sync, it'll immediately switch over to this updated configuration. If there are no reserved environment variables that meet your needs, you can create your own custom environment variables for whatever makes sense for your project, and then write firmware that looks for those variable updates and changes your project accordingly. And doing all of that is going to be a big focus of our next video. In general though, this is the flow that I personally use when I need to add configurability to my projects. First, I look for a reserved environment variable. There are reserved variables for a lot of super common configuration our users do, so there's a decent chance you can just use what's already available. Next, if a reserved variable does not exist for what I need to change, I'll define my own variable and then use it in my host firmware. Finally, the last and most powerful option you have available is host firmware updates. Notecard and NoteHub provide a mechanism for updating host firmware, and through host firmware, you can do, essentially anything you want. Ideally, you wouldn't make entire host firmware updates just to change some configuration, but in a pinch, that is an option that's available. And we'll cover how host firmware updates work in our next video. In this video, we took a thorough look at how to configure a note card. We went through each of the most common requests you need to know, from hub.set all the way to card.wifi, and talk through the best way to configure each request based off the needs of your project. Now that we have our note cards configured, in the next video, we're going to start writing code. We'll talk about the note cards firmware SDKs, how to write production-ready code, and how to test your projects to make sure they're ready for a prototype deployment. If you have any questions on what I covered in this video, feel free to reach out in the comments or to ask in the Blues developer forum at discuss.blues.com. Thanks for watching, and I'll see you in the next video.